Hello, everybody. This is Cameron Dennis from the Blockchain Acceleration Foundation, also known as BAF. It's awesome to have you here today. Just real quick before we bring Keith and Wyatt on board, give you a quick lowdown of what BAF is and sort of what we do. So we're a 501c3 nonprofit that starts accredited blockchain courses at universities. We place people at jobs. We get people research opportunities. We're essentially a network of student organizations and blockchain professionals that are working together to push this industry forward. And today we have Wyatt and Keith coming to talk about the evolution of the internet and e-money. Maybe dive a little bit into DAGs, directed acyclic graphs, for those who don't know. But it's amazing for all of you to be here. So Keith and Wyatt, if you don't mind turning on your mic and camera, so we can get started. And for everyone, hello, everyone in the chat, if you have any questions or concerns, please drop them in the chat. Also, questions in the Q&A portion, which is on the sort of right side of the screen. You click it, and then you can write whatever question. We'll upvote the ones that the community wants to hear, and then Keith will sort of ask those at the end. And then if you just want to sort of chat throughout the workshop or event, just drop them in the chat section. But Keith, take it away.
Hey guys, this is Keith. I do a little bit of communications with the BAF network. And today we have a special treat. We have Wyatt Meldman-Floch here with us, the CTO and co-founder of the Constellation Network, which is building honest data for a connected future. I love the tagline. All my friends, I showed them the big video. It's really cool. But I just quickly kind of wanted to talk to you. We're just going to chat back and forth a little bit about the internet today. Let's talk about Web3, DLT, kind of like how that's changing the way the internet works today. And then I want to get around kind of like what's holding it back. And then I think that'll smoothly transition us right into what you guys are doing. So quickly, if you'll just introduce yourself, tell us about your background, how you got into DLT, why Constellation?
Hey, great to be here, everybody. Really appreciate it. Yeah, so a little background. I'm Wyatt. I'm the tech guy in Constellation, but the Constellation is my baby. It is something that I sort of have been working on, I'd say, for many, many years without really realizing what it would become as I was working as a data engineer. So someone who focuses on software that processes large amounts of information. Typically, it's like the main end goal. Yeah, I guess I'd say, like, if I were to give you a descriptor of me, I have very much like a traditional like software computers type, well, not really traditional, I have a physics and math degree, but like I worked as a software engineer for many years, like in the data space. And I just got really into crypto, actually, during Occupy Wall Street, but I've been sort of following tangentially for many years. And I just noticed that, some of the things that I've been doing in my, day-to-day could really be applied to making, everything that we are into here actually scale and getting it to actually, be integrated into, applications you use day-to-day. So, yeah, that's me.
Yeah, so that definitely helps us get started. So when you first started looking into DLT, I mean, were you deep into like Bitcoin? Was it Ethereum that really did it for you, or like what kind of got you sparked in the first place with DLT?
So I first, heard about Bitcoin during Occupy Wall Street when I was in college. I thought it was, it was kind of in the same, the vein of everything that was going on. It opened up my sort of realm of possibilities. And, I really didn't have much of a directly into the DLT space. However, until the last few years, I'd say the last few years of my working as an ordinary engineer, I saw the success of Ethereum, and I am a real big believer, in sort of the mission here. And to be totally honest, what got me into the space and made me say, hey, like, I think I need to put my foot in the ground was when the Plasma white paper came out. So I've been following it for a while. I've been like going through it wasn't Geth, and then there was what was the one that was written in Rust? that I think like Gavin Wood's team did. Anyway, I was going through their shit and parody. And so I just realized fundamentally that this entire thing space has the perspective on how software can, or like what its limitations are and how it should be built from like about 10 years ago, from like a monolithic architecture type of like standpoint. And I basically built an entire career off of building scalable backends, using microservices and sort of some of the new in vogue approaches. And I realized, hey, like, if we reformulate the way that we think about what consensus is actually doing in terms of small axiomatizable components, something that could even be treated as like a map or reduce job, then we could actually perform consensus on that much easier than trying to rely on a global state change.
Cool. So let's talk a little bit about how the internet works today, right? Like, let's keep it super simple. I don't want to confuse anyone. I think the easiest way to start is kind of talking about hypertext transfer protocol. When everyone's typing in the website, they see HTTP or HTTPS, and that's where you kind of interact with the web browser and whatnot. Talk to us about a little bit of that and like kind of how the data flows back into these networks. As a data engineer, I'm sure you have much better terminology that you can use about what's happening there.
So I actually spend most of their time on web. I apologize if I totally botch everything, but so HTTP is essentially a way of creating some type of a like a linking between just different text, and so as opposed to what am I thinking about? I actually wrote this down because I wanted to differentiate this word with the word partitioning. Give me 2 seconds. But yeah, in essence, it's a way of indexing, lexicographical information, I think you could say, or just text docs. And so for the most part, everything that's actually on the internet, if it's not some kind of like embedded JavaScript, it's really just text. I mean, at the end of the day, like it's a string. And so we basically found a way to create a network, I guess you could call like topology. Yeah, that'd be the right way to describe that for what we call ISPs, in such a way that when you're actually querying information, it looks up information that is of the textual format in a like efficient way, such that you can load your web page. And so, yeah, that's sort of where we are right now. I don't think necessarily like so that's what I'll say where we are now. And I'd say that the limitation that we currently see is that information that is stored online doesn't necessarily have any topological information to it. I'd say topological in the sense that is different than a network topology, but the sense that data itself has some type of a relationship or relativity to a larger data set itself. This sort of gets into the concept of data provenance from those who are, to drop a buzzword, but I'm thinking about it more so in terms of machine-to-machine communication and the verifiability of like microservices or componentized systems. So sort of where we're going is that we need to create some type of a verifiability to information that's uploaded online. And this is less so, I mean, it's very much so for us as well. I think that it's going to take time for us to create applications in order to basically differentiate memes or tropes like we see in the news, or the idea that somehow someone with a credential, with an opinion, is somehow more valid than a verified data point, in order to sort of seep into our day-to-day life. But on the machine level, this is like a quintessential issue, like directly, for any machine learning algorithm that's trying to learn about you or figure you out. I mean, I could point to a ton of different articles out there on bias and how also, folks. Yeah, I'm not going to get into it, but yeah, there's a lot of dodgy stuff that we've got there, but also it really relates to a safety component. So as we move towards an autonomous world, if bogus information gets fed into some type of a program that ordinarily thinks it's doing the right thing, it could actually really it could kill people. And this is the main kind of focus for more serious endeavors like our LiDAR initiative and as well as the Air Force. So global situational awareness applied locally to machines, I guess you could say, is where I think we need to head.
Yeah, cool. And definitely, I think one of the things that I found you guys too is kind of that Moby initiative, where you guys are working with all of these car manufacturers to make sure that we can create these autonomous vehicles, and that's one of the biggest things with, device-to-device communication right now. Also, quickly, Wyatt, I'm hearing a little bit of scratching from your audio in the background. I think it's getting to the audience as well. I'm not sure if there's anything you can do about it. But
let me see. Can you hear me any better now?
It still has kind of like this crackling in the background. I'm not sure exactly where it's coming from. I don't hear it now. I also can't hear you.
How about now?
You sound much better.
Okay, wonderful. That's the lucky microphone on monitor number 3. Great.
Okay, cool. So yeah, I mean, we were just kind of talking about adding that new layer of topology to the internet, right? So that's very cool stuff. But before we dive too deep into that, I definitely do want to get into it. I kind of want to pick your brain a bit about regular blockchain and DLT a little bit more. Let's talk about kind of consensus protocols. Let's talk about how you guys have differentiated the consensus mechanism compared to where Bitcoin and proof of work, and where you guys see the issues with things like
Yeah, totally. So where do I begin? When Bitcoin came out, the way that we built things was much different than the way that we build them now. So in general, a lot of the internet was built in terms of what we would call a Ruby on Rails monolith. And typically you have some kind of a central main component application, which then is, basically you have some giant app with a bunch of different components that are all connected through this one, thing that's deployed. Keeping track of that, as we found, and we need to add features, rapidly, iteratively, and we also need to come up with scalability solutions. This didn't quite work beyond what was required of the internet in the late 90s. So we saw a massive shift in how some major tech companies, I think most notable would be Twitter and Netflix, at least I use their, Death Star diagrams in my talks all the time. They noticed that, the same kind of aha moment that I think that that we all did when we realized that certain types of programs are embarrassingly parallel. And those embarrassingly parallel programs can be sped up using, well, not concurrency, but by distributing them across, many different, resources or many different servers in order to, achieve the same task. So essentially, think about it in terms of streaming. You can basically split up, just streams between 2 different channels. I guess I'm afraid to use the word socket server because I'm going to screw this up. But basically, we want to try and flatten the architecture of our backend as much as possible. And the reason why is because in any situation where there is a unnecessary hierarchy, you essentially create some type of a feedback loop where that thing can then kill everything else underneath it. Even irrespective of, the issues where, let's say that you have all your web apps deployed on replicated servers of the same Rails monolith. If you really needed to speed that up, you could also distribute the resources available on a collection of machines towards that problem as well. So we come to the birth of microservices. This was important, I promise. So Bitcoin and the current systems were all built in that sort of older paradigm that didn't necessarily take advantage of the scalability aspects of a distributed system. I'd say that a global consensus that doesn't operate using some type of convergent algorithm, which we and some other projects use as well, it just fundamentally isn't going to scale. You're basically relying on an entire distributed system that was designed in order to perform operations in parallel and then make all of them agree upon the same operation within the same state shift. It's just antithetical to the problem. So, these things were they work. It's just we needed to adapt them for how we build modern backends. And so that's really kind of and where I kind of came in. And yeah, maybe we'll take a pause and say if we want to talk a little bit more about differentiators with existing DLT.
Yeah, sure. And I guess to bring it back for people who may have been a little bit lost, I want to talk about Bitcoin and proof of work, right? Because I think one of the interesting things that it kind of said for the world was we can distribute almost kind of, these energy resources to someone else, but now it has to be done, like you're saying, it has to be done in this sequence, like everyone has to agree upon it, which is really crazy. But I think that proof of work, making people mine to or stake energy resource as exogenous resource, which is super interesting in the proof of work mechanism because it's a real energy that you're expending to get this Bitcoin. And and I know that you know on a governmental level kind of how this causes issues, and the same thing with proof of stake, where you're kind of just staking, you're just staking your interest in a way, or maybe you have a better way to say that in the protocol. So if you can talk about maybe the governance even of how that's causes issues.
Yeah, absolutely. So look, first off, I don't want to knock on proof of work. It was really an important step where folks just needed to create some type of a. I mean, how would I put this? You needed some type of an economic game to tie in node operators in the beginning, and proof of work really solved that problem. It also sort of forced individuals to provide, basically invest on their own understanding of their infrastructure and resources to make sure that they didn't, accidentally try to submit a double spend. Although, I mean, obviously you have to do that. You have to work on it. But what I'm getting at is, by tying that economic aspect, it kind of, helps self-govern things. What I'd say is that I think that the shift currently is moving towards what I'd call like a useful proof of work. I've said this before we shifted from proof of mean to proof of reputable observation like ages ago. The REP model is still called mean, by the way, I promise you. But here is that while proof of work is essentially just an arbitrary calculation that we can tie some type of an economic value to, we can expand that in order to make proofs much more useful and much less, I guess you could say, wasteful in the sense of, the way it works is that essentially it's a semi, I wouldn't say random, but you take the last piece of, the hash and then you use that to calculate a difficulty, and then everybody has to sort of reverse engineer a thing. We can find, different tasks for a computer to do that are verifiable and can converge to some global verifiable state. So globally verifiable state. Now, naturally, in a centralized system, what you want to do is try to have a few really strong master nodes that orchestrate your total, any kind of distributed system. So think about something like in terms of a Spark cluster, I guess you could say is the thing I always go to. Spark is kind of like a new type of Hadoop. I mean, it's not really new, it's been around forever now, but I'm old. And basically what happens is you have some type of a centralized, executor, as we call it, which executes, your operations, federate, and then monitor operations that happen amongst like worker nodes. And so essentially that's what you're trying to do with proof of stake. The idea here is that if individuals own so much of the stake in the network, then we can just give them a master node and they can sort of like basically process stuff. We can have other nodes as well, try to perform some type of useful task. But it is like definitely one approach to scalability. But I found it personally antithetical to what we were trying to achieve with consensus. And so like, from an ethos perspective, also a technical one, I promise you, but from an ethos perspective, I really want to keep staking out of consensus, at least on the lowest two levels in DAG. It would actually really screw things up technically too, and that's kind of why we got to LTX, which is this is where we get to have fun. And so I'll explain why that would screw stuff up technically later. But in essence, it started out as an ethos, and then it became the actual solution to a scalable like DLT network was, moving away from staking towards something around like a reputation model or a machine learning algorithm that learns about itself over time.
And why they're getting a little bit of influence again on the mic.
Oh,
I think it's feedback from it. It may be at least.
Let me maybe try a different microphone. I apologize for this, guys.
No worries. So yeah, I mean, definitely find it interesting how, proof of stake creates this master node idea. I think. Go ahead and talk again.
Any luck? Oh,
I think we hear you now. I think the mic
okay.
is sounding. I think it's good now.
My apologies. I will switch. I'm just switching back and forth. I'm like Jinx. I have the worst technical luck. I feel like it just stops working.
Yo, the mic's not working, man. No, sure.
Yeah, it's the mic anyway. Oh, so you were saying, so we were talking about staking in terms of
yeah. I mean, just diving deeper into kind of what you guys were solving with the DAG at this point. I mean, kind of how there's not this one master node that is trying to solve scalability or trying to make everyone come together. That takes too long and is inefficient. So let's talk a bit about the directed acyclic graph and how that materially changes things.
Yeah, totally. So, by the way, please stop me at any point, just like wave or something, if my sound goes off, we'll switch it. How to put this? A directed acyclic graph is a really special type of data structure. And the reason why is that it has what we call a poset topology or a partial ordering. Okay, and what that means is that there's some relative notion of before and after, or like the building blocks for what we would use to create time. This is like actually how relativity works. And I could send some really cool stuff about distributed systems and special relativity and that to you as well. But the clock syncing problem in relativity is the exact same one in distributed systems. They are one and the same. And so the reason why a DAG and this random data structure that you might have heard of from some algorithms course somewhere comes up is because it is able to incorporate a relative time, I guess you could say, a relative sort of awareness of its state versus like the global state of itself versus society or something like that, in such a way that if there is we can define a sort of like master ordering, if you will, or like a global ordering to all of the like local DAGs, such that if we calculate, let's say every node keeps like a little calico stitching of the DAG locally. If we collect all of those and stitch them together, they will implicitly carry the information on the data itself that tells you what order it went in. So this is how we're able to solve the problem of time. It's literally it at the end of the day. And so that's why we use it.
Absolutely.
I mean, I learned from smarter people, dude. I'm just doing it. But I mean, Leslie Lamport has an amazing talk on this too. I mean, I remember when I was in college, it just blew my fucking mind. And this is the kind of stuff that I just had to like keep reading about during my day job to stay sane. When I was just a regular programmer. Like I came from a research and a physics background, and I guess this was kind of like a spark inside of me that helped me motivate to just keep moving. So don't lose your spark. But yeah, so back to why a DAG. So sorry, go ahead.
I just said word, man. Go ahead.
Yeah, word, seriously. So why a DAG? So, well, forget about the acyclic and the directed part. We'll talk about that later if necessary, but just know that the directed and the acyclic part is what we use in order to determine some type of a DAG. What's really important about using a DAG is that it's a graph as opposed to a linear data structure. So in a traditional sense, like on Bitcoin, I guess sort of hand waving over Merkle roots and this, that, and the other. It's essentially just a linked list of blocks, right? So, what you want to do in some type of, or not what you want to do, but if we wanted, one of the simplest things that I've thought of, or rather the thing that I guess is where it started and it was true to the very end, is that why don't we just have a bunch of blockchains happening all at once and then just like twist them in order to create some type of a partial ordering? And so that's literally it. So at any given moment, at least for Constellation, and I think in many comparable projects, I'm really out of touch, by the way, I think with other projects in the space. So anybody's out there, please connect me. I went into a hole after 2018. It was just like, all right, I'm gonna finish this shit. So happy to check your stuff out and share. But there are other comparable projects that did this too. And essentially by creating that twisting between different blockchains that are being created, you create some type of a partial ordering. Now, I believe that's how Hashgraph works. I believe, I don't know, I don't want to speak ill of anything else or incorrectly. However, yeah, that was a concept that had been explored by a few different folks a few years ago. Now, what makes Constellation different, and I think I will just jump in here and add a little bit, is that unlike the stitching together of a graph of independent blockchains, what we do is we actually form a tiling, which is why I called the state channel project tessellation. It's kind of, I don't know, play on Penrose tiling or something like that. But essentially what we're trying to do is create a surface area such that at any given tile in the surface area, there is a guarantee or a quantifiable guarantee that forging something before or after is difficult to some quantity. I'm being intentionally vague because we can go deeper there, but that's it. So, yeah.
So that's super interesting. I guess to try and make sense of that, I wanna try and make sense of that. So you're twisting these blockchains together to kind of create a partial ordering, so that maybe you could have interoperability between these blockchains and understand what's happening. And so the next thing that you guys are doing is actually creating a surface. Now that part of it is probably very mathematical and not something that I could understand and probe you too much for. But once we do that surface area, I think that you talked about the quantifiable guarantee. And I think you guys, that stuff really matters with the DoD, right? You guys have a cool partnership with the DoD. So I think that really explains the best, if you want to dive into that a bit, about why this quantifiable security or quantifiable guarantee of what's possible here. To talk about kind of.
Yeah. Totally. So it definitely, ties into, what the DoD wants. I think this is a huge, I'll let them speak for themselves, but I will say a high level, what's really great about working with these dudes is that they do their own research and they know they want you before they talk to you. And I think one of the main sort of quantifiers or the main things here is that, for what they're concerned with, having some type of how would I put this? Our DAG structure adds greater guarantees than a traditional blockchain, because at any given step, so like our DAG is essentially made up of triangles. And it literally is made up of triangles. And the reason why is because we needed to create like this total DAG out of what we call a simplicial complex, which is sort of like a fancy math way of describing like polyhedra or like geometric objects in like higher dimensions. Okay. It sounds more complicated than it is. I mean, like the fun shit is in physics, but in real talk, this is like actually what goes into database design, creating connectors to DBs, stuff like that. I mean, it really is dimensionality reduction under the hood. So in essence, what we want to do at any given time is create a new triangle from two parent references of other triangles, such that it follows a distribution, like one on nodes themselves, so they can help partition themselves, as we call it, or rather they can facilitate consensus. This is the facilitator selection logic. And then the actual, the reason why we use that distribution as well is because it basically, how do I put this? We want to make sure that hashes are not able to collide with one another. I mean, it really gets down to that. So we want to make sure that we distribute the amount of tip references to the amount of children. So you have two tips, one child, it goes like this, in such a way that we can guarantee complexity of all the different hashes. By guaranteeing that complexity, we know that within any given layer within the DAG, that the computational complexity and or the cost to reverse engineer that is X, Y, or Z. So I haven't released like these formulas and stuff yet because I want to get them right, and it's actually, I do know how to make it work on the DAG layer. This is going to go into generative economics, which is coming out very soon. And so the point I'm getting at is there's a reason why we want to keep DAG. So DAG is it follows what I've called, I think someone else called it this too. Maybe I made this up myself, I don't know, but I took it from differential geometry. I called it an L-star topology, where there's essentially like an infinite amount of layers that can exist around some sort of central homotopy or some sort of, I guess you could say topology, but homotopy in the sense of like how, holes work out so that you can essentially describe the state of your system using like a language. I'm going super deep here, I apologize, but the point I'm getting at is we want to keep DAG very simple. It is DAG itself, the actual, like our token, is layer 0 and layer 1 of, the hypergraph network. And so they're layer 0 and layer 1 on top of like numeric objects, like just, balance updates. And so what I mean by that is that at any given time, we might create what we call a state channel or some other type of data that, is processed through either its own personal network or like maybe a wire joinable, subnet of HGTP. And so in order to make sure that that data can commute, that basically we can make sure that data from your state channel, Keith, to mine, Wyatt, let's say that we both have L3s, and we want to, ensure that one, we can do like cross-chain atomic swaps, and two, I can basically write an application that's L4 out of both your and my state channel. We need to make sure that there is a relative scale to all of the different state channels at their various different layers in that like L infinite topology. And so just very succinctly, by making sure that L0 and L1 define a global scale, like literally just an e to the x function of like, how do we define exponential scale, then it will allow for quantifiers, measures, and metrics, like metrics between like state channels and a state channel itself to define a measurable quantity in the same way that like NIST creates some type of a measure or a metric for a quantity. So that's the magic under the hood. That's like just by making sure that, we have these triangles and we use, this type of, this guarantee that it's, exponentially impossible to try and reforge this different layer. And the way that we've designed that, by making it really simple with 0 and 1, allows for cross-chain liquidity across any different state channel and literally any other protocol. So that's why LTX is it's like our first cross-chain, atomic swap project. It's like, it's not hard. It's not hard for us. I mean, I'm serious. Like literally, like we don't do like, there's no color tokens, man. Like you literally have a blockchain in a box, or a DAG in our case. And if you follow our deployment practices with the main DAG network, I mean, you have a native token, you have cross-chain atomic swaps with any other token in the DAG network and any other, blockchain network that's integrated at the DAG level. And this is what we need. This is what you should have had this whole time. So
wow, wonderful, beautiful, and quickly here. So I'm trying to wrap my head around the surface area thing still, right? So we got the triangle. I'm guessing the reason the triangle makes the most sense is because that's the most basic shape that you could basically use to define all of these things or try and quantify things.
Yeah, exactly.
Okay.
So yeah.
Interesting. Yeah. And so now though, I do actually want to talk a little bit more about DeFi itself. Just some of the phenomena that's happening in that space in general. I think, you said you're kind of plugged out, so that's okay. But I think that you'll definitely have some insights as to how Lattice will actually open up everything that's happening there, and you can take it from there because I know you've got cool stuff about Lattice.
Yeah, totally. So part of the one of our technological, I wouldn't say limitations, but in order to allow what I just mentioned about cross-chain atomic swaps for anybody who, just creates a Constellation HGTP state channel, we need to make a couple of, I wouldn't say assumptions, but guarantees about the types of operations at the very lowest level. And so things like staking, things like, liquidity pools and whatnot don't make sense from an ecosystem perspective to be implemented within the DAG token. But that being said, I mean, dude, this is literally like, so DAG is basically just the first implementation of an HGTP, network. So basically, when we create Lattice, we're essentially just going to create our own subnet with HGTP that is able to process and perform these types of calculations on whatever hardware we want, completely concurrently, except for confirmation times on the ETH network. So like Lattice is going to be like every single fucking thing you can do with DeFi, even more, and it gives you the ability to leverage against high transaction fees and the inability to offload from these different types of tokens and whatnot. So yeah, I guess from sort of like that high level, I mean, what's really great about Lattice is that we can basically build our own DeFi without the limitations of a smart contract. So we have all that and more.
Super cool. I think something that will trip people up is the idea of getting rid of smart contracts. And we've already gone pretty deep into basically how I think that's possible. But if you want to take a second here to I think that's going to throw a lot of people off. You said in one of your videos, even like smart contracts are gone in 10 years. And I love that. So tell me a bit about how you guys are making it where you don't even need that.
Yeah, well, to be honest, I really do stand by it. I just don't see smart contracts like holding up to a new paradigm of true end-to-end authentication. So essentially, like any kind of smart contract-based app requires some type of trusted relay, as they call it. So it's like, I mean, why am I using a pool of computers to run something when it's all executed from my own central database anyway, kind of a thing? There's very little things that you can do autonomously within a smart contract, and that's sort of what I'm getting at. Obviously, NFTs, although we're doing a project with that. But there's stuff you can do with it, but fundamentally, the Oracle problem, at least as far as I've seen it in terms of solidity, it's just like they're not even trying anymore. So basically, the reason why I say that smart contracts are on the outs is because this new approach of using a reputation system or a machine learning model in order to self-govern, reorganize, and then basically validate data or whatever through your network is itself a solution to the Oracle problem. So our state channels themselves are oracles. Like you create your own consensus oracle that can process any data from any source that you want. You give it whatever type of, and I'm not kidding here. Like you can run a Turing complete program. As long as it follows our type system within how a like a cell works. So the cell, I'm not going to get into it, but it's essentially like a future for HGTP as opposed to HTTP. There's a huge issue with Insolidity, which is that verifiability was done not at the type level, but at the opcode level. And so a workaround around this was to not allow for, was to force termination of programs after a certain time. That's not necessary when you actually move into what we call types or abstract representations of data that have topological relationships. And if there is a global topology upon which all of the data, is what we call covariant, or it's like a child of, then we call that a graded computability model. And within that, we can actually find out at compile time whether or not your thing is, well, one, is it going to run forever potentially, and we'll let you know, and two, I mean, it shouldn't, technically speaking, if you actually follow what we tell you within the types. But yeah, you should be able to verify a program just at the type level at compile time. I mean, the same way we do now.
And I think we got some of that static again, man. It's going to switch up some lights.
Let me try to. Okay.
Not yet. Don't hear you yet. Yeah, it was working good for a while. Let's see. Are you talking now? Can't hear you yet. Yeah. Something that I think will kind of, I can't hear you yet, by the way. Bring us back to what's happening. I think actually there's some deep things I want to get into here about your partnership with the Quant Network as well. And you're muted now, by the way. I don't know if you know what, or if you're connected to your mic already. And also we have a question. Actually, we'll take that first. Thanks everybody for tuning in for this. This has already been super fun. And we're about to get even deeper into some of their partnerships. So definitely stick around, and also opportunities to network at the end. There's some really cool people in here. So hang out for a second. We're gonna get Wyatt to come right back in. Anybody see anything cool today? Any cool announcements that came out? We've definitely had a lot of stuff happening in the blockchain DLT space recently.
All right, I'm back. Can you hear me?
Yeah, we hear you.
All right, thank God.
Welcome back, man. So if you didn't have anything that you wanted to specifically follow up on, someone did ask, what programming languages will people have to know to build on the Constellation Network?
Great question. So currently, with the design choices that were made a long time ago, it should work for any JVM language. So, Java, Kotlin, or whatever. It's natively written in Scala, but anything that can compile down to a JVM bytecode should be verifiable. Assuming that, I don't know if that, actually I take that back. There might be a caveat with something else, but as long as the type system holds out, it should be fine. And the Java type system, which is what the Scala one comes from. So yeah, anyway, and we will be, allowing for other languages in the future. Not allowing, but I basically need to create some type of an adapter to the Scala/Java type system to other programming languages. I've seen a awesome project out of Statebox in the Netherlands that I'm following, and I think that I think there's some real magic there.
Cool. Yeah, absolutely. And then quickly, another cool question was, how do you guys expect to onboard a community of DeFi builders? Which, I mean, I guess go ahead and just take that question. It's not necessarily directly competition for you guys, but what does it look like for you to see a DeFi builder on your platform?
Yeah, so how are we aiming to attract DeFi developers?
That's what someone asked. I don't know if it makes sense, but tell me.
It does make sense. I think it does make sense. So as I was saying before, we can essentially re-implement the same types of functionality that those have within like DeFi type, contracts, but from a different lens, actually, by treating them as their own kind of process that is defined algebraically is actually the differentiation here. But the thing here is that we can basically, any DeFi developer who already has an existing contract or project can, one-to-one, swap and connect to new features on the Constellation Network. And I think that the simplest feature that's worth mentioning is creating a what do I call it? A reconciliation, I think. Channel. So essentially we can, validate and verify trades or transactions in batch, if you will, in a much faster way, and then relay them back to DeFi contracts. So I guess, from that known problem that I've seen, we're going to try and tackle that stock. So essentially, if you're having issues with pulling, your, funds or something with confirmation times and gas prices, then you should be able to at least create, a confirmation or reconciliation on the Constellation network, and then have that show up on the Ethereum one as well.
Cool.
That's just one use case.
Yeah, and so someone else asked, is the Constellation Network live?
Oh yeah, no, we launched mainnet a long time ago, probably like over 6 months ago. Yeah, it's totally live. If you'd like to be a node operator, please sign up. We basically had kind of like a rolling batched onboarding period to prevent clusterfucks in the network. So we're gonna double in the next, like, by the end of the year, I believe. And then yeah, I think we should be further along next year with just everything and having our governance together, as well as having a long-term plan on how we want to do on-chain governance in order to open the network up. So we basically just did this because we wanted to teach enough people at the right times how to onboard other folks and create some type of communication amongst like support chats and stuff. So basically, folks who have, who've been really helpful have come out of the woodwork and been our, first node operators and help form our governance model, which is what we're going to, translate into an on-chain governance implementation. I have some opinions on how I think what that's going to look like, but yeah, I'd say next year everything's going to be totally opened up, and then governance will be. I think we'll probably open up mainnet before governance. I'm not totally sure yet. They'll probably come at the same time. But yeah, so we're really fortunate that we haven't had any insane hiccups, and I salute my node operators and our governance guys for help keeping the clusterfuck out of the cluster.
Yes, sir. Good stuff. And next question, and this is something that I'm super, super curious about myself. I started digging into DAG first, but then after I realized how I even found you guys, which was some of the things that were going on with the Quant Network. And some people are interested in the audience about kind of how you guys are interacting with them and kind of what role they play, especially with the actual QNT token and the DAG token. People are curious. But I would love to hear kind of a little bit about why Quant matters to what you guys are doing.
Yeah, totally. So in terms of like a token, type partnership, there's not really anything I'm, at liberty to divulge. But not to elude anything, but essentially we have come close to them because they have a strong background in the finance world, and we have a strong background in the data world. And so naturally, in order to get either of our sort of networks off the ground, I think that there needs to be a scalability component, and there is some knowledge of the industry. And so we've had just a lot of, I guess you could call it, I don't want to, geez, this sounds so lofty. I mean, we've given some talks and we've met, with various folks at the Quant Network, and are sort of hashing out something that we can do to help each other's projects in a mutually beneficial way. I hope that wasn't too vague. I just
no, that's cool. That's cool.
Yeah.
I want to kind of play around with language here a bit too, though. So the Quant Network, one of the things that they're doing to solve interoperability is kind of they've created this over ledger operating system where people can now create these multi-chain applications and send data back and forth. So I think the whole point of kind of what Quant Network is really doing is kind of making it to where we can have rules over what's happening in these spaces. It feels like that's kind of what the solution is used for. But I'm interested in so is this Quant sitting in a place where they would basically use the DAG inside of what they've built and have that DAG structure being sent across their network? Or are you guys even swallowing them in a way, or how would you say that would relate?
Well, I think that gets down to design choices on the Overledger side. However, we are something that, we are something that would sit underneath Overledger anyway. So depending on how they want to roll, I mean, they will connect to our hypergraph ecosystem by creating a, Overledger state channel. And depending on how they want to interact with other, projects, they could either directly do, some type of a, two-phase transaction over Ledger with a different protocol, or they could rely upon, something like Lattice if they needed, something to speed up confirmation times, etc. So, yeah.
Cool, man. I appreciate it. I appreciate that. Really cool stuff. So I think honestly, I've touched on, or at least I've had all my notes ran through, and you've given me tons of stuff to study afterwards. So thank you so much for all of that. That was awesome. If you have any other quick thoughts you want to get out about maybe Lattice, I think you said there was maybe something specific that you wanted to let out about that. I don't know if you can or not. But any other parting words or kind of just stuff to kind of chat about for the next few minutes?
Yeah, no, absolutely. Yeah, I mean, so Lattice is, I guess I'll just leave you with this. I'm really excited about Lattice because it's our first, real application within the Constellation ecosystem. And I think it really solves a definite problem that has been asked or has been brought up. And I'm personally just stoked to use my thing for more than just financial transactions, So this is the first on a long road to come. I think we have a few other flagship projects that will be coming out next year that we haven't announced. I at least have one that everyone watching this knows about what I'm talking about. I have that one. So I'm just really excited to expand the ecosystem. And I really hope I guess my takeaway for you guys is this. And also I apologize that I've had this probably about a month before I'm actually going to release and demos of the house state channels and our monadic execution context will work. But our goal here is that we want to try and to give developers the ability to create their own base layer, but with the same level of complexity that it takes to create an HTTP server or something. Or to make an API call using a future. And so with that in mind, and to think about each one of these different, we call it a monadic execution context. We'll just call them a future right now, or a cell. I mean, they're called cells in the Tesselation repo, but
right. Yeah.
Yeah.
Go ahead. Oh, go ahead. Yeah. I mean, there's definitely also some questions that I want to dig into, but keep going.
Sorry, last thing. Essentially, the cell, that kind of thing, is the entry point to your end-to-end authentication channel. And that's it. You can sort of linearize it in your head. You shouldn't have to really think about how consensus works under the hood unless you're trying to do something that's a little bit more complex, in which case, welcome. Welcome to the team. But yeah, that's where we're trying to go, and this will make sense once I'm done with the next release. So, stay tuned.
And I guess just a few more questions we have from the audience here, if you don't mind. I think you touched on this a little bit, but I think someone specifically wants to hear about what Lattice and Dagger are doing for DeFi that cannot be done today on Ethereum or Polkadot with that extra layer of interoperability.
Yeah, totally. So I really I'm not an expert on Polkadot. I believe I have a high level understanding. However, I don't think I would be able to answer that simply because I don't know their protocol enough and I don't know how they handle oracleization of off-chain data. But so I apologize, and to whoever asked that, please feel free to come after me, or at least just let me have it. I don't know. I'd love to learn. So, yeah. So in essence, I think that folks are running into issues with gas prices again on ETH, especially. There's been an issue where certain folks are having trouble accessing or making modifications to liquidity pools or just certain knobs and levers or whatever to a DeFi contract in such a way that, the type of, not buffer, but the delay in verifying their transactions, it basically turns everything into sort of a race. And so that makes things kind of difficult. So, what we try to do is actually allow for off-chain resources to perform the validation step for a smart contract. So like basically if you wanted to, process streams of information in a DeFi contract, through some type of a chunking or like, buffering system that we could implement, where we'd actually take a chunk of a ton of transactions verified and use that as the payload to the contract. We should in general be able to make, like a two-phase confirmation that allows for folks to at least get some type of a reconciliation on the DAG network side, even before ETH confirms. So that's kind of what we're trying to do is provide like almost maybe even like arbitraging on resources as well. I mean, especially depending on, whether the, DAG the LTX network is being used as opposed to, a particular DeFi contract. There's many different, things that can be done with that. So, yeah, God, I'm sorry if that's not too high level. I mean, I'm really talking about that one use case because, you can do some exotic stuff with the DeFi things. And
yeah,
so
and you talked about leveraging. Basically, now that you'd have this extra layer on top of all that stuff, you'd be able to leverage the fact that there are high fees on, say, Ethereum or something like that. You said something very.
Yeah, that's exactly it. It's basically like an arbitrage between transaction fees.
Okay.
So like, I mean, in DAG, like we're freemium. I mean, like you can send one free transaction every snapshot, which is roughly 45 seconds. And you literally just have to send anything. And then you can send one within that window. I mean, literally a sat. And then we just rank them based upon, what, fees were paid by individuals. But that free model is pretty much like, for the most of us, I mean, that's kind of takes care of business here. So I think there's a lot of opportunities to create alternative infrastructure that can better support Ethereum at a lower price.
Cool. And so something that confuses me about the feeder structure really quickly is kind of how I imagine that what for sure I think you've explained about that is how it's kind of a communication and a transaction at the same time. Tell me if that's right or wrong.
This is actually this is a great question. So let's differentiate two terms, okay? Let's differentiate a transaction and state, or a state channel, a state update. And so I can do this in terms of L0 and L1 of our handy dandy hypergraph network. So L0, which is the lowest level, gossip convergent protocol where we try to converge to a global state at any given time. That is the layer upon which we would actually confirm, potentially we would go from a sort of fuzzy view of reality to, confirming that into a, distinct, strong structured block, I guess we call a snapshot. And so a transaction is on the L1, and a transaction is actually just a new link in a linked list that actually forms our DAG. So without getting too complex, the DAG is actually made up of transactions that are not transactions. We stuff them into blocks, but we actually create the partial order on the transaction level, such that from an individual's address or an account, when they actually want to make an update to their account in the ledger, we enforce them to define a topological order. So L1 is where we actually do consensus. We determine blocks. We can run them in parallel across nodes. We can produce a fuck ton of these guys. And then at any given minute or so on a time trigger, we then kick off this global convergence process, which then takes all of these transactions, tries to determine if there are any conflicting ones, if there are any tiles that are scaly that stick out, or they're they basically create a non-uniform surface, and that's what we solidify into state. So the lowest level is actually the protocol is the highest level of our awareness of state in the network, and then L1 is how we actually make those incremental changes, and that's a transaction, and that's how we've been talking about it.
Ah, okay, that makes sense. Wow, that's interesting. Okay, and then Here we go.
Hey, how's it going?
Good.
Well,
Hey.
howdy ho. This has been super awesome. We're unfortunately out of time. We should be moving forward to the networking portion. Why it'd be awesome for you to stick around, get to meet some of the community.
Absolutely.
There's probably a good amount of devs in this, going to stick around too if you want to kind of dive deeper in the sort of what it takes to start programming on the Constellation Network. I think is a good opportunity. For everyone else out there, thank you so much for joining. Real quick, it's actually really funny. Wyatt and I met in person a while back. I know the crazy times when we meet in meetups at USC. Just sort of like stayed in touch, on Twitter and these various channels. So I'd highly recommend following him on Twitter, following Constellation Network on Twitter, newsletter, whole 9 yards. It's a super cool project. I see it going places. And besides that, we actually just secured during this meetup our next meetup. It's funny, we're constantly playing catch up over here, but we're managing to host one every week. So we're going to be running one with Zcash, well, specifically the electric coin company. And you will learn how to, it's pretty much the basics of Zcash and then how to run shielded transactions on the Zcash network. And that is going to be with blockchain at UCLA. So that will be next Wednesday, same time. I got the link live. So for those who are still here, please, you can sign up right here. I think I just dropped it. Yep. And besides that, if you're not quite yet a member of the Blockchain Acceleration Foundation, this is the best way to do so. You just fill out this BAF membership application. It's completely free. This is how we ensure that we're providing the content that you want. This is where we are essentially ultimately trying to create an automated nonprofit organization that provides opportunities to our members. So this is where we find out what you want and what we have to give you. So yeah, this is the place to do it. Stick around for networking. Once you fill out the membership application, you get access to our Discord, recruiting programs. We're even place people in actual labs and getting them positions for graduate school. So it's slowly coming together. And super stoked for everyone to be involved. So turn on your mics and cameras, and we'll hop into discussion. Thanks, everybody. Thank you, Wyatt. Thank you, Keith.
Thanks, everybody. Pleasure.
Thank you for doing this.